You woke up this morning. You lay there for a moment, in the warmth, in the particular tangle of sheets and thoughts that belong specifically to you. Your plans for the day, your half-remembered dream, the slight stiffness in your neck, the thing you said 3 weeks ago that you are still replaying at inconvenient moments. The full weight of your life pressed in around you before you had even opened your eyes. Your worries, your ambitions, the person you're trying to become, the person you are afraid of remaining, all of it felt, as it always does, enormously important. It is, and it isn't. Both of these things are true simultaneously, and the tension between them is one of the most productive and most ignored facts about the human condition. We are, by the measure of most conceivable yardsticks, vanishingly, almost comically small. We live for a handful of decades on a rocky ball orbiting a thoroughly average star in the outer suburbs of a galaxy containing several 100 billion other stars, in a universe containing 2 trillion other galaxies, which may itself be one of an unimaginable number of other universes, and which has existed for 13.8 billion years and will continue to exist in one form or another, for timescales so vast they defeat any honest attempt at comprehension. Against that backdrop, you, your worries, your ambitions, your particular tangle of sheets, are small. Not metaphorically small, not small in the way that a poet means when they call a human being a grain of sand. Actually, literally, measurably, definitively small. And yet, the universe has been around for 13.8 billion years and has produced, as far as we know, exactly one kind of object capable of understanding that it is small. One kind of matter that can contemplate the scale of things. One arrangement of particles that looks outward at the cosmos and feels, genuinely feels, not merely processes, something in response to what it sees. That arrangement is you, and people like you, and the entire strange, improbable, cosmically brief project of conscious life. This is the story of what the universe's scale actually means when you measure it honestly. Scale of space, scale of time, scale of matter, scale of complexity. It is a story about insignificance that does not end where you might expect. It follows the numbers wherever they lead. It does not flinch at the conclusions, and it begins, as most confrontations with scale must, by establishing just how large the thing is that you are being asked to feel small inside of. The numbers that should unsettle you start with distance. You are familiar in a rough way with distances at the human scale. The walk to the shops, the drive to the next town, the flight across a country or a continent. These distances feel large when you are experiencing them and comfortably manageable when you look at them on a map. They are, by cosmic standards, so small they barely exist. The distance from the Earth to the Moon is roughly 384,000 kilometers. The Apollo astronauts took 3 days to cover it. If you could drive there at motorway speeds, it would take about 5 months. This feels like a long way. It is, by cosmic standards, nothing. The distance from the Earth to the Sun is about 150 million kilometers. Light covers it in 8.5 minutes. The fastest spacecraft humanity has ever launched would take several years. The Sun is, by any human measure, unimaginably far away. And the Sun is our nearest star. The next nearest, Proxima Centauri, is roughly 4.2 light-years away. That is not 4.2 times further than the Sun. It is about 270,000 times further than the Sun. At the speed of Voyager 1, the most distant human-made object in existence, it would take approximately 75,000 years to get there. We launched Voyager 1 in 1977. In the time since, it has covered about 0.002% of the distance to our nearest stellar neighbor. We have not left our neighborhood. We have barely stepped off the front porch. The Milky Way is roughly 100,000 light-years across. The observable universe is about 93 billion light-years in diameter. The full universe, extending beyond what we can see, is almost certainly vastly larger still and maybe infinite. Now consider time. The universe is 13.8 billion years old. The Earth is 4.5 billion years old. Life on Earth has existed for roughly 3.8 billion years. Complex multicellular life for about 600 million years. Modern humans, Homo sapiens, our own species, have existed for somewhere between 200,000 and 300,000 years. Recorded human history spans roughly 5,000 years. The average human life is roughly 80 years. Set against 13.8 billion years, your 80 years is a fraction so small it does not have a common name. It is about 6/10 millionths of the current age of the universe. If the universe's age were compressed into a single calendar year, the entirety of recorded human history would occupy the final 14 seconds of December 31st. Your own life would be gone in a blink, a fraction of a single second, invisible at any normal speed, and the universe's future dwarfs even its past. It will continue, in one form or another, for timescales measured in tens of trillions of years at the minimum, and in the deeper future of black holes and quantum silence, for timescales that make the current age of the universe look like a blink. Your 80 years, measured against the full span of cosmic time, does not merely vanish. It was never visible to begin with. Now, consider matter. The observable universe contains roughly 10 to the power of 80 protons. That is a 10 followed by 80 zeros. Every atom in every star, in every galaxy, in every cluster, all of it added together. You are made of roughly 7 times 10 to the power of 27 atoms. That is a large number. But relative to the total number of atoms in the observable universe, you are approximately 10 to the minus 53 of the whole. Less than 1 part in 100 billion trillion 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 trillion. These numbers do not have human meanings. They resist intuition, but they are not wrong, and they are not going away, and they are, if you will let them, genuinely useful things to know. The address. It may help to establish, with some care, exactly where you are. You live on the Earth. The Earth is the 3rd planet from the Sun, orbiting at a distance of approximately 1 astronomical unit in the habitable zone. The narrow band of orbital distances at which liquid water can exist on a planetary surface. The Earth has a mass of roughly 6 times 10 to the 24th kilograms and a radius of about 6,371 kilometers. It is, in the inventory of solar system objects, a middle-sized rocky planet. Not the largest. Jupiter dwarfs it. Not the smallest. Mercury, smaller. Unremarkable in its size. Exceptional, as far as we currently know, in its biology. The Sun, our star, is a G-type main sequence star, which astronomers sometimes call a yellow dwarf. It has a mass of roughly 2 times 10 to the 30th kilograms and a diameter of about 1.4 million kilometers. It has been burning hydrogen in its core for approximately 4.6 billion years and has roughly 5 billion years left before it exhausts its fuel, expands into a red giant, and ends the current chapter of the solar system's history. The Sun sits at a distance of roughly 26,000 light-years from the center of the Milky Way. In the Orion Arm, one of the smaller spiral arms of our galaxy. Our galaxy contains between 200 and 400 billion stars. The Sun is not one of the brightest, or the largest, or the hottest, or the most massive. It is, by almost every stellar measure, average. An ordinary member of a large collection of ordinary stars. The Milky Way is a member of the Local Group, a small cluster of roughly 50 galaxies, most of them small, dominated by the Milky Way and the Andromeda Galaxy. The Local Group is a minor subcluster on the outskirts of the Virgo supercluster, also called Laniakea, which contains roughly 100,000 galaxies spanning about 520 million light-years. Laniakea is itself one of many superclusters in the observable universe, each one a vast filament or node in the cosmic web of large-scale structure. The observable universe, the full sphere of space from which light has had time to reach us, contains about 2 trillion galaxies and roughly 10 to the 24th stars. Your address in full is a specific arrangement of atoms on a specific rocky planet orbiting a specific average star in the outer suburbs of a specific medium-sized galaxy in a specific small cluster on the edge of a specific supercluster in a specific region of a universe containing 2 trillion other galaxies. There is no version of that address that sounds important. The pale blue dot. On the 14th of February, 1990, the Voyager 1 spacecraft, then approximately 6 billion kilometers from the Sun, well beyond the orbit of Neptune, turned its camera back toward the inner solar system and took a photograph. The image that resulted is one of the most consequential photographs ever taken. In it, the Earth appears as a tiny point of light, pale blue, barely distinguishable from the noise in the image, suspended in a scattered ray of sunlight passing through the camera's optics. The entire planet, with all its billions of human inhabitants, all its civilizations and histories and wars and art and science and love, fits comfortably within a single pixel. The astronomer Carl Sagan, who had campaigned for years to have the photograph taken, wrote about it with a clarity that has rarely been matched in the literature of science. He pointed out that every human being who ever lived, every king and peasant, every act of courage and cruelty, every religion and philosophy and ideology that has ever seemed important enough to fight for, occurred on that mote of dust suspended in a sunbeam. The photograph was taken from within the solar system. From the distance of Proxima Centauri, the Earth would be so far below any detection threshold that it would be completely invisible. From the center of the Milky Way, the Sun itself would be invisible to the naked eye. From the Andromeda Galaxy, our entire Milky Way, with its hundreds of billions of stars, would appear as a faint smudge, a small member of a small cluster. From the edge of the observable universe, our galaxy would be invisible. Our Sun would be invisible. The Earth would be invisible. You would be not merely invisible, but inconceivably, categorically, immeasurably, beyond any conceivable detection. This is where you live. This is the scale of the place into which you have been born. And understanding it, really understanding it, not just intellectually noting it, but actually letting the weight of it land, is one of the most important and most consistently avoided experiences available to a human being. The timescale of nothing. But perhaps the most vertiginous form of insignificance is not spatial, but temporal. Consider what the universe was doing before you existed. 13.8 billion years ago, the Big Bang. The universe began in a state of extraordinary heat and density, expanded rapidly, cooled, and within the first few minutes forged the hydrogen and helium that still constitute the vast majority of all matter. For the first 380,000 years, the universe was an opaque plasma through which light could not travel. Then, as it cooled enough for electrons to combine with nuclei into neutral atoms, the cosmos became transparent, and the first light streamed outward, now seen as the cosmic microwave background. For hundreds of millions of years after that, the universe was dark. No stars, no galaxies, no light of any kind beyond the fading glow of the cooling plasma. Just hydrogen and helium slowly clumping under gravity in an absolute darkness that nothing alive today would recognize as the same universe we inhabit. Then the first stars ignited. The first supernovae seeded space with heavy elements. The first galaxies coalesced. Generations of stars were born, burned, and died over billions of years. The heavy elements they forged, the carbon, oxygen, nitrogen, iron, calcium, were scattered into the interstellar medium and incorporated into new generations of stars and planets. Our solar system formed about 4.6 billion years ago. The Earth formed within its disk, cooled, gathered water, and somewhere in a young ocean, roughly 3.8 billion years ago, chemistry crossed a threshold we do not fully understand and have never replicated in a laboratory. Life began. For the next 2 billion years, life remained simple. Bacteria, single-celled organisms, invisible to any future eye. Nothing that any conceivable observer would have found interesting. Then, roughly 600 million years ago, multicellular life arrived. Animals appeared in the fossil record. Over the following hundreds of millions of years, fish, then land animals, then reptiles, then mammals, then primates, then hominins. Our own genus, Homo, appeared about 2 million years ago. Our species appeared roughly 200,000 to 300,000 years ago. You appeared somewhere in the last 100 years. From the universe's perspective, you arrived approximately now. You are, in the deepest sense, brand new. If the full history of the universe were compressed into a single calendar year, modern humans would appear at approximately 11:52 p.m. on December 31st. Your own life would occupy a fraction of the final second. And when you are gone, in 80 years, or 50 or 20, depending on circumstance and luck, the universe will continue for timescales that make its current age look brief, for hundreds of trillions of years, for eras so long that the names we have given them feel inadequate to the sheer, featureless, almost incomprehensible length of time they describe. You will not be present for any of it. The luck of existence. And yet, before dismissing yourself entirely, it is worth examining the other side of the ledger. You exist at all. This is, on reflection, a genuinely extraordinary state of affairs. The chain of events that had to occur in the exact sequence and with the exact properties that they occurred in. For you to be here reading this is so improbably long that any attempt to calculate its probability quickly becomes meaningless. Consider only the astronomical prerequisite. For there to be a planet capable of supporting life, you need a star of the right mass. Not so massive it burns out in millions of years before life can evolve. Not so small it tidally locks its planets into airless frigidity. You need the planet at the right distance for liquid water. You need the right mass for gravity to retain an atmosphere. You need protection from bombardment at the right level. You need a large moon to stabilize the planet's axial tilt. You need billions of years of relative geological and stellar stability. The probability of any given star system having all of these properties simultaneously is low. The number of star systems in the observable universe is roughly 10 to the 24. Both facts are simultaneously true, and together they leave the question of how common life is genuinely and deeply unanswered. But that is only the beginning of the chain. For you specifically to exist, every ancestor you have ever had needed to survive long enough to reproduce. Not just your parents or their parents. Every member of an unbroken lineage stretching from you back through every generation of Homo sapiens, through every hominid before us, through every primate, through every mammal, through every vertebrate, through every multicellular animal, back to the first self-replicating molecule in the warm shallows of a young planet. At every point in that chain, an unbroken sequence of survivals. Every ancestor you have ever had survived long enough to reproduce in an environment that killed most of its contemporaries. Every egg fertilized by the right cell among millions. Every embryo that developed rather than failing. Every childhood disease survived. Every predator evaded. Every famine endured. The probability of any specific person existing, you specifically, with your particular face and memories and anxieties and slightly stiff neck, is so close to zero that it cannot meaningfully be distinguished from zero. And yet here you are. You are, in the most literal sense, an improbable event. A specific arrangement of matter that the universe has never produced before and will never produce again. Not approximately, not poetically. Actually, physically, never. The rarity of complexity. There is a deeper way in which you might be considered significant, and it requires understanding something about the structure of the universe that is often overlooked in discussions of cosmic scale. The universe is, in almost all of its volume, unimaginably simple. The vast majority of the observable universe is empty space, void, essentially, with the occasional atom drifting in isolation. The average density of matter in the observable universe is roughly 5 or 6 hydrogen atoms per cubic meter. 5 atoms per cubic meter. The interstellar medium within a galaxy is vastly denser than the cosmic average, and even there, the density is millions of times lower than the best vacuum achievable in any laboratory on Earth. The universe is almost nothing, almost everywhere. Where matter does accumulate, in stars, in planets, in cold gas clouds, it forms objects of limited complexity. A star is, at the level of physics, not a complicated thing. It is a gravitational compression of hydrogen that drives nuclear fusion. The physics is subtle, but the range of states a star can inhabit is not large. A star is hot gas. That, essentially, is what it is. A rocky planet is somewhat more complex. Its chemistry is richer. Its geology is dynamic. It can host a vast range of mineral structures and atmospheric compositions. But a dead planet, and most planets as far as we know are dead in the biological sense, is still fundamentally just chemistry. Atoms bonded in various configurations, driven by energy from above and below. And then there is life. Life is, and there is no other honest word for it, a different category of thing. Not different in the sense that it violates any law of physics. Different in the sense that the complexity of even the simplest living cell is orders of magnitude beyond the complexity of any non-living structure in the universe. A single bacterial cell contains thousands of different proteins, each one a specific sequence of hundreds of amino acids, folded into a precise three-dimensional shape that determines its function. It contains DNA, carrying millions of base pairs of genetic information, a molecular archive of evolutionary history stretching back billions of years. It contains membranes, molecular motors, signaling cascades, metabolic networks of extraordinary intricacy. All of this maintained in dynamic equilibrium by the continuous expenditure of energy, processing information, responding to its environment, replicating. Nothing else in the observable universe, not a star, not a galaxy, not a black hole, comes close to this level of organized complexity. And a bacterium is the simplest form of life we know. You're not a bacterium, you are a mammal. A collection of roughly 37 trillion cells, each one as complex as that bacterium, each one specialized for a different function, communicating through electrical and chemical signals, organized into tissues and organs and systems of staggering intricacy. Your brain alone, the 3 pounds of electrochemical machinery generating the experience of reading this sentence, contains roughly 100 billion neurons, connected by 100 trillion synaptic links, maintaining a dynamic web of electrical activity so complex that it generates, through some mechanism we do not yet understand at all, the experience of being you. There is nothing else in the observable universe with anything approaching this level of complexity. If complexity is significant, and there is a reasonable argument that it is, that the universe's capacity for organized information processing is the most remarkable thing it ever produces, then you are not a rounding error in the cosmic ledger. You are, in a very specific and non-metaphorical sense, one of the most extraordinary phenomena in the observable universe. The only witness. There is another dimension of significance that scale alone does not capture. The universe, as best we can tell, does not know that it exists. Stars do not know they are burning. Galaxies do not know they are rotating. Black holes do not know they are swallowing matter. The cosmic web of filaments and voids does not know it is the largest structure in the observable universe. Dark energy does not know it is driving the accelerating expansion of space. The universe is doing all of these things, all of this extraordinary, improbable, cosmically structured activity, in complete, perfect, total ignorance of itself. Except here. Except in the small, warm, brief, improbable pockets of organized matter that we call conscious minds. The only places in the universe, or at least the only places we know of, where any of this is witnessed, where the expansion of the universe is noted, where the birth of stars is observed, where the fate of the cosmos is contemplated, where the laws of physics are discovered, written down, argued about, tested and refined into something resembling knowledge. The universe is, as the physicist Freeman Dyson observed, in some sense aware of itself only through the minds that have evolved within it. Whether this constitutes a deep fact about the relationship between consciousness and matter, or merely a careful observation, depends on philosophical commitments that science cannot adjudicate. But the observation itself is not poetic, it is accurate. The universe is old and enormous and mostly empty and almost entirely unconscious. And in a tiny, specific, recent corner of it, something happened that made contemplation of the whole possible. Your mind is, the universe looking at itself. The scale that makes you feel small is the same scale that gives your existence its particular character. You are not small despite the universe being large. You are remarkable because the universe is large and indifferent, and you are, somehow, neither. The Copernican series. There is a historical thread worth following here, because the shrinking of humanity's sense of its own cosmic importance has not happened all at once. It has happened in stages, each one a shock, each one eventually absorbed, each one leaving human self-understanding permanently altered. The first great demotion came from Nicholas Copernicus. In 1543, Copernicus published his heliocentric model of the solar system. Before Copernicus, the dominant view placed the Earth at the center of the universe. The sun, the moon, the planets, and the fixed stars all revolved around us. We were, spatially, the most important place. The universe had a center, and we lived on it. Copernicus removed us from the center. The Earth orbits the sun. We are one of several planets, not the pivot around which everything else revolves. A passenger. The shock was real and prolonged. The conflict between the Copernican model and the prevailing worldview was not merely scientific, but theological and philosophical. To be removed from the center of the cosmos was, for many, to be removed from a position of special significance that the cosmos itself seemed to confer. The demotion was only beginning. As telescopes improved, it became clear that the sun was not at the center of anything either. It was a star, one of many. By the early 20th century, it was understood to be one of hundreds of billions of stars in the Milky Way, orbiting the galaxy's center and the suburbs. Then, in the 1920s, Edwin Hubble established that the fuzzy nebulae visible in the night sky were in fact separate galaxies, entire islands of stars at enormous distances from our own. The Milky Way became one galaxy among billions. Then came the discovery of the Big Bang. The universe had a history, a beginning. We arrived late, very late. Then the accelerating expansion of the universe. The realization that the cosmic future is unimaginably vast and that everything we know is a tiny and temporary flame in an otherwise cooling dark. Each of these discoveries was a contraction of human significance. Each was resisted for various reasons, and each was eventually accepted. The picture that has emerged from this sequence, this accumulated series of astronomical demotions, is the one we have been exploring throughout this script. We are small, we are temporary, we are peripheral, we are late, and we are the only things in the universe, as far as anyone knows, that have noticed any of this. What the philosophers said. This confrontation with cosmic scale is not new. It predates telescopes. It is one of the oldest preoccupations of human philosophical thought. The Stoic philosophers of ancient Greece and Rome, Epictetus, Marcus Aurelius, Seneca, We're acutely aware of the smallness of human life against the backdrop of time and the cosmos. Marcus Aurelius, writing his Meditations in the 2nd century CE, returned repeatedly to the theme of the brevity of human existence, the narrowness of human experience, the speed with which even the most celebrated lives are forgotten by history. He did not find this depressing. He found it clarifying. The vast, indifferent scale of time and space stripped away the things that did not matter and threw into sharp relief the things that did. Reason, virtue, the quality of your attention to the present moment. Blaise Pascal, the 17th century French mathematician and philosopher, articulated the vertigo of cosmic insignificance with unusual directness. He wrote of being terrified by the eternal silence of infinite spaces, a sentence that contains, in 12 words, the full emotional content of confronting the universe's scale. But Pascal did not conclude from this terror that human beings are therefore meaningless. He concluded the opposite, that the human capacity to know and feel the terror is itself a form of greatness unavailable to anything that is merely large. A tree does not know it is a tree. The universe does not know it is the universe. You know both of these things. That knowing, Pascal argued, is worth more than any physical magnitude. Pascal writing in the 1660s, Sagan writing in the 1990s, both arriving at the same essential insight from opposite directions. The scale of the cosmos is not a refutation of human significance. It is the context within which a specific, peculiar, observational kind of significance becomes possible. The universe does not confer significance on you by being small enough to comprehend. It confers significance on you by being large enough to be worth comprehending. The Fermi question. There is one question that, more than any other, sharpens the paradox of cosmic scale and human significance. Are we alone? If life exists elsewhere in the universe, if the 2 trillion galaxies, each with their hundreds of billions of stars, harbor biology on other worlds, minds on other planets, civilizations capable of their own version of this conversation, then human beings are significant in the way that any one person in a crowd is significant. Real, individual, irreducibly themselves, but not unique in kind. Not the sole example of the thing they are. If life does not exist elsewhere, if the extraordinary improbability of its emergence means that in all the vast volume of the observable universe, Earth alone has produced biology and consciousness, then the situation reverses almost entirely. We are not a common phenomenon in a large universe. We are a singular one. The only minds, the only witnesses, the only place where the universe's existence is known to itself. The question of whether we are alone is called the Fermi paradox, after the physicist Enrico Fermi, who asked the question in its simplest form over lunch in 1950. If the universe is so large and so old, and if life arises wherever conditions permit, then by now there should be civilizations millions of years more advanced than ours. Where are they? The silence is profound and unexplained. Various resolutions have been proposed. Life may be extraordinarily rare. The emergence of self-replicating chemistry from non-living matter may be so improbable that it has occurred only once in the observable universe, or a very small number of times. Intelligence may be rare even among living things. The step from biology to technology, capable minds may be a bottleneck that most life never crosses. Civilizations may be self-limiting. through the same forces of conflict and environmental disruption that threaten our own. The distances involved may simply be too large, and the lifetimes of technological civilizations too short for any two to overlap in a way that permits communication. None of these explanations is confirmed. The silence continues. If we are alone, we are not insignificant. We are the universe's only self-knowledge, its only mirror. Its one chance in this observable region at least, to look at itself and understand what it sees. That is not nothing. What we do not know. The honest account of cosmic insignificance has genuine uncertainties woven through it at every level. We do not know whether life exists elsewhere. Despite the apparent abundance of potentially habitable planets, estimates suggest there are billions in the Milky Way alone. We have found no evidence of biology beyond Earth. This could mean life is rare. It could mean it is common, but not yet detectable. We genuinely do not know. And this uncertainty matters enormously, because whether you are one of quadrillions of conscious beings in the universe or the only conscious being in this entire observable region are very different states of affairs. We do not know whether consciousness is common even among living things. The biological history of Earth suggests that intelligence capable of technology is not an inevitable product of evolution, but a contingent one, a specific solution to specific environmental pressures that might not be replicated on every world that hosts biology. Whether the universe is full of observers, or whether observers like us are rare or unique is not known, not estimated with precision, not known. We do not know the full extent of the universe. If the universe is genuinely infinite, then every possible arrangement of matter occurs somewhere, including other versions of Earth, other versions of you. In an infinite universe, uniqueness becomes philosophically awkward. You are not unique in an infinite space. You are one of infinitely many. The significance of consciousness as a phenomenon is not diminished by this, but the significance of this specific instance of it becomes harder to articulate. We do not know what consciousness is. The experience of being you, the specific, immediate, irreducibly personal quality of your awareness, is, in the current state of neuroscience and philosophy of mind, entirely unexplained, not partially explained, not mostly explained. We have no scientific account of why any physical process, however complex, should give rise to subjective experience. This is the hard problem of consciousness, and it is hard in the precise sense that no one knows how to approach it, let alone solve it. What you are, the experiencing thing inside you, the thing that feels small when confronted with the cosmos, is as genuinely and deeply mysterious as the cosmos that makes it feel small. Both the container and the thing it contains remain, in important ways, unknown. Small enough to matter. You woke up this morning. You know more now than you did when you started. You know the address, the unremarkable star in the outer suburbs of an average galaxy, in a small cluster on the edge of a supercluster, in a mostly empty, observable universe that may be infinite. You know the timescale, the tiny sliver of cosmic history you inhabit, the almost incomprehensible length of what came before and what will come after. You know the numbers, the 10 to the 80 protons, the 2 trillion galaxies, the 10 to the 24 stars, against which your 7 times 10 to the 27 atoms barely register. You know that you are small, cosmically, measurably, inarguably small. But you also know the other side of the ledger now. You know that complexity, genuine, extraordinary, unprecedented complexity, is vanishingly rare in the universe. That the vast majority of the cosmos is hydrogen drifting through a vacuum, that stars are churning simple processes, and dead planets are inert chemistry. And the cosmic web is beautiful, but mindless. That consciousness, the thing happening inside you right now, the thing generating the experience of reading these words, is, as far as anyone knows, one of the most remarkable phenomena the universe has produced in 13.8 billion years of trying. You know that you are improbable, that the chain of events required to produce you, from the Big Bang to the first star, to the first supernova, to the formation of the solar system, to the origin of life, to the evolution of complexity, to the specific confluence of biology that produced you, is so long and so contingent that your existence is not merely unlikely. It is, by any reasonable calculation, a fact that almost did not happen and somehow did anyway. You know that you are the universe's witness, that the scale which makes you feel small is known to you and unknown to itself, that in all the vast, cold, dark, silent volume of the observable universe, the number of places where that vastness is contemplated is very small, and you live in one of them. And you know, this is the part that tends to arrive quietly, somewhere after all the numbers, that insignificance and significance are not opposites. They are not on a single axis, with important at one end and trivial at the other. The universe's size is not an argument against your mattering. It is the context within which your particular, specific, unrepeatable kind of mattering becomes possible. You are small, you are brief, you are, as far as the evidence suggests, one of the most complex and improbable arrangements of matter in the known universe. You woke up this morning, that is, against all the odds, a genuinely remarkable thing to have done. You've been watching the entire history of the universe. Don't forget to like and subscribe, and leave a comment to tell us what you think. Thanks for watching, and we'll see you next time.